Hey, what's up, Logic fans? Welcome to our third video on section 5.4 on identity tableau. So this is video 5.4c, and let's just pick up right where we left off. We're going through some of these more sophisticated examples. Could you please provide me with an interpretation in three objects that makes statement 2 true, and an interpretation in three objects that makes statement 2 false? Pause now. Okay, so hopefully you had a chance to look at this, and I've got this template here. So if you were stuck, see if you can pause and do it from here. But let's start discussing this. So sentence 2 is obviously very similar to sentence 1. Okay, the order in which these are presented is reversed, but you can tell from our rule of inference comm that in fact that order isn't going to matter so much, and we will discuss the rules of inference with the quantifiers in section 6.1, so look there for that. But they do differ with the universal and the existential quantifier, and that does change things. So unlike 1, this just needs at least one thing in our domain, that is A, B, or C, okay, to satisfy this description, okay? So looking at this part of it, right, this is the y equals a part. Notice we do not have the a equals a because that's considered trivial, okay? You could present it, it wouldn't do any harm, but it would have to have a plus, okay, underneath of it. Now, what we do need to know, though, is since there's at least one thing in there, so either a has to be this way, B has to be this way, or C has to be this way, or possibly some combination of them. So we've got B is identical with A, and we've got C is identical with A here, okay? So that's the basic sort of setup. Now, if we want to make this true, we need at least one thing that has the property F and is identical with A, okay? So you could choose the object A, all right, just like put a plus here, and it's trivial that A is identical with A, and that's kind of understood. But to take a less trivial case, something like this would work, right? So the object C here has the property F and is identical with A. And the idea is sort of fill in the rest however you like, and this is going to be an interpretation of this sentence according to which it's true, okay? So that's a really, really good one to think about, okay? So let's try to do the false case now. And go ahead and pause if you had trouble, if you couldn't solve this one. Maybe you can do the false one now that we've discussed it a little bit. This says there's at least one thing, A, B, or C, that satisfies this description. So to make that sentence false, right, what we need to do is we need to think about making nothing in our domain satisfy that description. Okay, in other words, you could think about it as making this statement true. Okay, so we're going to make this statement false, so nothing can satisfy this description. So A can't satisfy it, B can't satisfy it, and C can't satisfy it. Well, if I had minuses across the board here, that would be okay, right? And notice you're not going to engender correspondence issues because these all have the same. Okay, so whether they're identical or not identical, it isn't going to matter. But the point is that since everything lacks F, nothing's going to be both F and something else, right? So that's one way of doing it. But, maybe we want to do a little bit more sophisticated example. So let's think about this for a second. Let's suppose we had A and B A and C this way, but we had B this way, okay? Now what would happen? Well, we've got to be a little bit careful here. We already know that the object A does not satisfy this description, and we know that the object C does not satisfy this description, but so far B might. So we need to make sure that B is not identical with A in order for this to be a interpretation according to which sentence 2 is false. Okay, so that would be yet another interpretation according to which sentence 2 is false. Okay, and that's kind of how we're working things out. Let's check for whether there's any identity correspondence issues. Suppose C was identical with A. That works out. Okay, so yeah, no identity correspondence issues. You're good with this alone. All right, let's talk about Oh, but wait, actually, I forgot to check the positive case here for 2, that an interpretation according to which sentence 2 is true for identity correspondence issues. And there is one that could crop up. Since C is identical with A and C has the property F, you have to have a plus here. That could not be filled in with a minus, okay? And then potentially you could go further, because if B were also identical with A, you would have to have a plus here. But if we just went ahead and put a minus there, then we could have a plus or a minus here. So glad we caught that. And these are the kinds of things you have to note. So sort of at the end, you know, I sort of go back through and check, are there any identity correspondence issues that could crop up, okay? And as you practice the practice problems, you'll acquire a facility with checking for that very quickly. And this is part of the reason why some of the identity stuff is more advanced, and I separate it into separate sections, okay? All right, moving on to the third one. I made a slight error, so I had to replace this with this. I had originally written this with an X here, but it's supposed to be a Y. So this is the third statement, okay? So go ahead, and I think the best way to start with this is, you know, for you to try to provide an interpretation of this in 3 objects that makes it true, and an interpretation of this in 3 objects that makes it false. So pause now, see if you can do that. I'll give you a hint in a second. Okay, hopefully you've had a chance to think about it, okay? But basically what we're doing is we're going to set things up like this. So if you weren't able to figure out how to set up your sort of table, this is how it's done. And so you can pause from here and see if you can complete it. But let me just talk a little bit about how I knew how to set this up, okay? Particularly, how did I know to put these guys here? Well, it all starts with understanding the sentence in question. And this is a really good example of a very common type of sentence that you will find in logic, in philosophy, in mathematics and computer science, okay? So let's really take a look at this and try to keep this example in your back pocket. Basically what this sentence says, okay, intuitively, is that there exists at least 2 things, and they differ with respect to the property F, right? One of them has that property and the other one lacks that property. So one of them's red and the other one's not red. There's 2 things, one of them's red and one of them's not red, okay? So there's an X, there's a Y, and they satisfy this description. They're not identical, so they're numerically distinct. They're not the same thing. There's 2 of them, okay? And, right, they differ with respect to F. X has that property and Y lacks that property. Okay, so this is a really nifty kind of construction, okay? But that means what we're thinking about here is pairs of objects, okay? So since we've got 3 objects, A, B, and C, okay, or we've got 3 individual constants, let's say A, B, and C, we have to think about the different pairs that might not be identical, okay? So the pairs in question are A is B, B is C, and A is identical with C. And those are the pairs among them, okay? So think about that for a moment, all right? And use this example to understand that. In fact, let me give you a small little exercise for 1 second. Suppose you had 4 objects, or 4 individual constants, I should say, A, B, C, and D. How many different possible pairs are there? Okay, so when there's 3, we just saw there were 2, like A is identical with B, B is identical with C, and A is identical with C. How many such pairs are there if there are 4? Pause now. Okay, well you can kind of do them out maybe this way. So you would have A is identical with B as one of them, you got A is identical with C as one of them, and then you got A is identical with D. Right? And then you've got the sort of B cases. So you got, you know, B is identical with A, but we've already got that here. Okay, so you're going to have B is identical with C. You're going to have B is identical with D. Okay, and then you're going to have the C cases, which are going to be, you know, C is identical with A, but we already have that here. Okay, you're going to have C is identical with B. We already have that here. But then you're going to have C is identical with D, which we don't have yet. Okay. So there would be 3, 5, 6 such possible pairs to consider if you had 4 objects, okay? So sort of thinking through the different possible pairs this way. And again, we're not including A is identical with A, B is identical with B. Those are considered trivial, okay? All right, back to the problem at hand. We have 3 individual constants, and these are the possible pairs we need to consider. So now that you've got this template, can you fill these in such a way, fill this one in such a way that this sentence comes out true, and fill this one in such a way that this sentence comes out false? Pause now. Okay, so we need 2 things to differ. They have to differ with respect to F. So one of them has to have it, and the other one has to lack it, right? And they can't be identical. All right, so at least one of our pairs satisfies this description, right? And that's exactly how you would write that. Now let's check for identity correspondence issues. It might help just to go ahead and actually make all of these negative. That way you don't have to worry about any kind of failed correspondence situations, okay? So this would be an interpretation that makes sentence 3 true. Now, can you come up with an interpretation that makes sentence 3 false? Well, sure, there's at least one pair of things that satisfies this description, right? They differ with respect to F. But if I just made all of these positive, for example, that would do the trick all by itself, right? Because there's not going to be any pair, whether they're identical or not identical, right, that satisfies this part, okay? So this would be an interpretation that makes it false. If we want to be, really sort of tight about it, we could say, here's our interpretation that makes it false. There's actually 3 things. A, B, and C are numerically distinct things, but they all have the property F. None of them differ with respect to the property F. Okay, so that would be a really, really nice way of doing things. Alternatively, you could, if these were all negative, the same principle holds, right? None of them differ with respect to the property F. Okay, so that's a really, really nice way of rendering this sentence false. And again, this is a really important example, so be sure to remember it and practice those practice problems in the text. Okay, so we've done a lot of groundwork now, understanding interpretations and how to present interpretations using Tableaux. And all that work's about to pay off for us, because in the next section, 5.5, we're going to define a lot of important, in fact, all of the important semantic concepts we'll be discussing in terms of Tableaux, in terms of interpretations. So we'll see you on that video.